Hello, hello. Alright, so I'm kind of excited for this next part because what we're doing now is programming how we add multiple rounds to the magazine. I have a much better time. These headphones are very sound canceling, so I can't really hear myself when I'm wearing them, which is fine. It just sounds really weird talking and not hearing myself, so I tend to talk too loud. Anyway. So where we need to go is here. And there's going to be kind of two parts to this. One, as we insert a round, it needs to depress the follower, scale the spring, and move any other rounds that are in here down. So that's the first half of it. The second half of it, though, is it should also apply a spring force back up against the cartridge you're trying to put in. So if you let go of a cartridge and you've only got it part way in, it should bounce back out. Right, so something like this, you know? Say I've got a cartridge, right? I'm trying to push it in, right? But it's halfway in, and I release it, right? It's gonna go flying, right? And that's what we potentially want to model slightly. It doesn't have to be quite to that effect, because we don't have like stiff to get that last one back in there. And that's part of the issue too. So there's that. Maybe that's the third piece, but I want it to be that you have to drag the mouse further. Similar to what we've already done with the slide release, right? So if you look at the slide release, well, I've got my speakers going through the wrong thing. That's fine, doesn't really matter. I'll fix it anyway. Sometimes this works and sometimes it doesn't. Boom. Uh-oh. That was weird. I lost it for a second there, but here we still are. Alright. So right here, if we latch this, that doesn't take much mouse motion to fully articulate that little latch, right? But now that it has the full spring tension of the slide up against it, it's going to take a lot more force to pull it down, right? So you've got this. This takes quite a bit of oomph to pull this down, right? So, yeah, right? It takes a really stretch. Whereas if I've got this back, it's ambidextrous, so I can do it from the other side. It doesn't take much force at all to operate that lever when there's no tension on it, right? But when there's tension on it, it takes a big, strong pull to release it. And that's what we're hoping to simulate here, and we've got it. So if we click on this knob on the gun, and we pull down on it, right? Come on, OBS. There we go. Click on the knob, and we pull down on it. See how much further I need to take my mouse? And I'm looking at two components. I'm looking at the speed of the mouse and also the distance the mouse has moved. Because right now, look how little my mouse is moving. Now it's in tension. The slide is being held by the slide stop. Now I need to either move my mouse really fast or quite a long distance. See how much further my mouse had to go for that. Anyway, the thought is we're going to do something very similar with inserting the cartridges, where as you get to the last cartridge, it takes a lot more finger pressure to get those cartridges in there. And that's what we're going to do, hopefully. So, what we're doing now is we're going to go to the script, and let's start with the follower and the spring. So for the spring, here's the spring. We could give the spring its own little script. I could see us doing this a couple ways. We could make an animation that was just 0 to 100. And then we could just play that animation in increments when we need it to. Or we can just put a couple simple functions to have it scale to a certain position. And then we figure out at what point we want it scaled for a given spot. I kind of like that idea, so let's try that. So let's attach a script to the spring. So this is a function or a script over here. So let's make some variables here. And let's see what we actually want that minimum scale to be, right? So let's pretend to put a couple cartridges in here. We'll put them at the position here, and then we'll rotate them the right way. Something like that. Pop them out at the top level. Okay. And then let's duplicate it and let's put 7 of them in here, because that's what should fit. Alright. Is that right? Feed system, 8-round detachable box magazine. Oh. Well, sir. We can put 8 in there. That makes sense, I suppose. Yeah, we knew that from playing Tarkov, I guess. Alright. So, this is what we're trying to make, is this beautiful thing right here. That's a nice picture. Alright. So, now, ours isn't going to look half as good as that. Like, see how their spring is, like, accordioning in a cool way? Like, we're not going to do anything like that. But the rounds should come, like, 2/3 of the way down the window when it's all full, right? So, that's what we're going for. So that's number 2. Duplicate it. This doesn't have to be perfect. Oh, I like how Godot is guessing how I want to name these. Cartridge 9 by 18 millimeter, cartridge 9 by 19 millimeter, cartridge 9 by 20 millimeter. they're getting they're getting longer and longer as they go down the magazine. All right. There we go. One limitation I have ran into is that these are all scale correct, right? So one Godot unit equals one Blender unit equals 1 meter, right? Which is fine. That looks about right for a full mag. Yeah. And doesn't look half bad. But now what we need to do is we need to take the spring and we need to scale it down. So right now the spring's transform is 1, 1, and 1. We're going to scale it on the Y dimension until it's all the way smushed. So the smallest we're going to get it is 5%. 5% scale. Or maybe 4% scale. Oops, that was the wrong unit. Oh, yeah, I was looking at the wrong thing. 20%. Yeah, there we go. Right there. Let's say 0.19. That looks about right. Because then the follower is going to go in between those. Yeah. Now, this is going to be a little wonky in that it's going to look smushered. Right? We're flattening the wires basically by doing this. But that's okay. So, let's mark that down in our script. The minimum scale, oh, it's pretty close. 0.18. Look at that. It was just a guess. And we might want to do 0.0. Just so it is marking everything as a float. So now, how do we scale things? It would be transform, right? I think that works. Something like that. There might be a better way to do that, but that's fine. So now I think I can scale this from 1% to 0%, or 100% to 0%, to indicate so if it's 0% compressed, it will be 100% expanded. Something like that. Yeah, we can figure out how we want to, how that makes the most sense in our other code. But um, then, if we go back to our magazine code, as we move the cartridge vertically, what do we want to do? As we move the cartridge vertically, right, so now the follower, we're also going to want a max position and min position. So if we look at the 3D version here, and we look at the follower, right, its current location in the y direction is this. So that's the follower max y. So let's look at the script here. Is that what am I selected the right thing? I think so, yeah. It's weird that its translation isn't applied, but it should be fine. Okay, so let's make a note for this. I'm just typing in bunk there for now, because what we need to do is actually move it and figure out where it should go. Let's hide the magazine for a second so we can just well, that's a little bit unfortunate. Can we get a wireframe view from here? Probably. We could unparent it, but I'd rather not do that, so oops. Okay, so there the follower is for sure too low. I think that's about where we want it. So that's going to be the minimum follower position. So it's actually negative 52 millimeters. Put it back up to the top. Negative 52. Now, really, this would be a good case for having an on-ready var. Just like that. Okay, now there's going to be a slight caveat to this. Well, hang on. We want to get rid of these cartridges. We shouldn't actually need those anymore, so we can go ahead and get rid of them for now. Then we want to fix the spring scale, so put it back to a scale of 1. There we go. So, there's one thing that we're definitely going to see happen here. That is something we're going to want to fix, which is the follower is going to move before the round touches it. But that's okay. See that? And it's also not springing back up, but that's okay. We can actually potentially use that to our advantage here. Okay, so the next thing we can do is we can scale the spring. We can scale the spring with with the thing. So let's get a reference to the spring. Just A, to make our code easier to read, and B, if we ever change this hierarchy, we'd have to fiddle with that, so we'd have to update all of these green things wherever they are, so that's fine, but it just makes it a little cleaner. It's whatever. Here we go. Now, is this going to work with the negative? Negative and negative is a positive, so it's going to actually add this to the distance. So yeah, I think that actually still works. I'm gonna have to think about that math for just a second. Right? Because we're kind of looking at a bit of a number line situation here. With a lot of this stuff, it seems. Right? So we've got our follower, and our follower is sliding along this number line, but the 0 point is actually like somewhere in here, right? Because what's our actual numbers? 26 millimeters and 52 millimeters, so yeah, the midpoint's actually here. This is 0. This is 25, 20, something like that. 26. This is negative 52 millimeters. Nice. Alright, I'm gonna be right back. A bathroom break. We'll do that in a minute. So, this is our follower's position, right? And it's sliding up and down like this. and we want a percentage of its travel from, 0% up here to 100 down here. And how can we math that out of these numbers over here? Well, pretty easy, I think, right? Because to get 0 at 26 millimeters, right, we would just have to say the position, which let's call that y, right? Minus (26 millimeters), and then convert to a percent, so times 100 or whatever. Easy. Now at this spot, right, it's actually the overall length is 26 plus 52, right? So I feel like this is a really easy geometry question. I'm just making it overly complicated, but that's okay. It's the overall length is 78 millimeters. So right. So we know that. And at this point, we have y, and we want to keep the formula the same all the way along. So at this point, it's traveled 26 millimeters, right? But the y position here is actually 0. So we're going to have negative 26 millimeters at this point. So we can actually do negative this, right? Times 100. And that would give us, well, divided by the length. So divided by 78. And that gives us 26 over because it's negative 26, but we flip it over 78. It's 33%, so 33%. Right? So, and then we could go back up and use this formula again up here, right? So P equals, does this still work? Negative y minus 26 millimeters. So y minus 26 millimeters is still 0. So negative 0 is 0 over 78 times 100 is 0%, which is good. And then if we go all the way down here, right, we get P equals, let's just make sure this still works. Negative, so y minus 26. So right now, y is extra negative, right? Y is negative 52. So we have negative 52 minus 26, right? So I think this works. Because so 52 negative minus 26, negative 78. Negative 78 over 78. This works, yeah. Equals 1 times 100 equals 100%. Cool. That's pretty easy. So that's how we do this. So right here, equals negative y minus follower max y over follower travel length all times 100.0. Alright, now let's just kind of make sure the spring and the follower move together. We're still not going to have the motion here correct, but oh yeah. Look at that. That's pretty cool. You see that? It compressed the spring and it moved the follower down. That's pretty sweet. That's pretty sweet. So now we want to do a couple things. We want it to spring back up to and including the number of rounds that are actually slotted into the magazine, right? But let's worry about that next. We also want to move all the cartridges down that amount. And there's a couple ways we could do that. We could parent them to the follower. That would work. Or we could just move each cartridge down with the follower. I think it makes the most sense to parent them to the follower, except that just makes it a little bit trickier for moving them around. Let's see what it would take to just move all of them. So the max cartridge is actually 8. I was mistaken about that. All right. So, we're going to have to do a little math here. So, first and foremost, all right. So then, let's try this. This would be the alternative to parenting everything to the follower, right? So potentially, if we've done this right-ish, we can now load more than one round into the magazine. Maybe. Let's see. Oh, yes. Now, there's going to be a gap between the follower and the cartridge, and the cartridges may be overlapping. So they're not quite correctly stacked, you see. But that's not so bad. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's the max that's supposed to go in there, so we've definitely gone ahead and stacked them a little bit too closely. So we're going to have to fix that. Right, so we need some more logic here. But it's looking okay. It's looking okay. So, how do we want to fix... Oh. We also haven't... Oh, we're removing the wrong ones. Okay, we've got a couple of problems to fix. We have a couple of problems to fix. So, so first of all, pop front. Let's try pop back. That's interesting. Did you notice that? It stopped depressing it. The last little bit of its travel. That's probably why we aren't getting the correct gap. I don't know why that would be. Okay, that's good. We're correctly popping them out of there now. So that's a plus. And there we go. We can't compress the spring any further. That's good. That's good. Now, another thing is, we need to make sure you can't click and drag the cartridge out of there if it's not actually the top cartridge, but you get the idea. Right, so that's reasonable because anyway, we've got some work to do still. We've got some work to do. Let's try to make this as simple as we can. So, the first thing I want to solve is how come it is that when I move it down, see, when I move it down, so far so good. When I move the next one down, the whole apparatus, including the follower and the next cartridge, continue to move down. Except for the last little bit of its travel. I don't quite get that. So let's look at the code and see what we actually are doing at that point, because that's when it turns the corner, right? Oh. Probably because we've got this 1 millimeter of snap. Yeah. I bet that's it. I bet that's it. So we have a couple options here. When we transfer it, we could snap it by 1 millimeter. Or we could get rid of this slough. Right? We could try that. It may be causing unnecessary complexity, right? I think that's working better, see? It still gets a little bit more downward travel that it actually does not reflect. So we try to figure out why that's happening, right? Because we've got this clamp effect here with the vertical min. It could be part of how we're computing this. Right? If that horizontal minimum z we might actually want to be using this value. Right here. That might be the explanation. Let's try it. Because it actually kind of snaps down. Yeah, I think that's it. Now they're going a little bit too low now. See that? Interesting. You know? Like that's a little bit lower in those feed lips than I feel like they should be. Oh? Well, we didn't take that one out because we took it out in the wrong order. We've got stuff to fix yet. We have stuff to fix yet. But that's a little better, and I'm not as concerned about the that correct position, although we could just change that slope a little bit to be a little bit less aggressive, right? So instead of negative 2.8, we could have it negative 2.3 and have it just not go down quite as aggressively. That feels better. That feels quite a bit better. Okay, another thing we could do to fix this is raise the entry position just a little bit. So it currently is at 59 millimeters. Let's take it up to like maybe like 62 millimeters, right? $61 millimeters. And then, let's see. It's actually reading those dynamically from the cartridge entry position. That's pretty cool. Okay. So then, what that may do is spread these cartridges out a little bit more so that they have the proper gapping. See? See how they've got more of a gap now? Now, it's kind of weird. It seems like it's inconsistent. Oh, it's considering it full. 1, 2, 3, 4, 5, 6, 7, 8. Look at that. Well, that's kind of cool. Yeah, the gaps between the cartridges don't seem exactly the same. Maybe that's just an illusion, though, of the like parallax. I'm not sure. Let's go with it for now. Let's go with it for now. Yeah. Oh yeah, that's pretty cool. That looks pretty sweet, actually. Um, Heck yeah. All right, let's see if we can thumbnail picture that guy. Cool. But we're not done, because there's two problems still. One, when you pop a round out, the other rounds should push up. And then two, there's a gap as you start filling it with the follower. Haha. Let's just take it out and then put another one in. We're going to start pushing them out the bottom pretty quick. Yeah. Okay. Okay. So far, so good. So far, so good. It did let us do a print screen on that. That's pretty cool. Kind of. That's weird. Ah, well. That works. Sweet. Cool. So, alright. So, what we need to do next is a couple things. First of all, easiest thing to do is let's get rid of the gap that we have when we have the first round go in. And that's pretty easy, right? So we can say let's figure out where that position is. So if we add a cartridge, undo that. There we go. Then we bring it out here. And we bring it down to where it just touches the follower right there. And we look at its transform. Yeah, that's 55 millimeters. So that is the number we want to go with. Okay. Cool. So that, hopefully, will fix the problem where there's a gap below the follower. Now the follower shouldn't move until the round touches it. Look at that. That's pretty sick. That's pretty hot. Huh? Right. This I feel like the spacing within the magazine is inconsistent, but I don't know. Here, let's load up another one and see what we get. Let's load them all from the top. I really like how these feel to load. Look at that smushed up spring as well. That's pretty cool. I'm excited about that. Okay, here's the question. Do the gaps between the cartridges line up? No, they kind of seem variable, don't they? Right, because here, there's a gap between cartridge 1, 2, 3 and cartridge 4 and cartridge 5. 5 and 6 are close together, and there's a gap between 6 and 7. There's a couple ways we can handle that. One is when a cartridge is captivated, right? I might take all of the cartridges below it and just gently massage them into a consistent spacing. Just so we don't have any gaps. Or we can just live with it looking like this. Like, it's fine. It's just a little cheesy that there's such a big gap. And it's not just the perspective, I don't think, because see how the gaps are different. You know? It's not a huge deal. We can live with it, but I think we can also fix it without too much trouble. So we just have a little function that we called cleanup cartridge spacing, and it would just say, hey, if there's 3 cartridges in the magazine, the follower should be here, the rounds should be here, right? And we just run that whenever you insert a new one, just so everything lines up nicely. I think that's not a bad idea. Alright. But before we get too carried away, Well, it might be a good thing to do first, actually, before we go to the next step, because the next step is going to be having the spring push the cartridges up under spring tension, and if they're not spaced evenly, we may get some interesting results with that math. So maybe we should clean up the cartridge spacing before we have the spring start pushing them up out of the magazine. Sure, I'm down with that. Let's take a break. Let's say that's a good chunk of progress. So, sweet. Thanks for watching. If you watched any or all of this, cheers.